Thank you so much for that kind introduction. I wonder who came up with that. Or actually, I do know, and I'll let you in on a little bit of a secret. It is us, the speakers, who write our own introductions. But nevertheless, I'm really happy to be here. And I know it's late, and the energy is a little bit low now in the afternoon. I also know that I'm one of these people who stands between you and those after conference drinks. But bear with me because I think that this topic is really interesting, and I hope that you'll find it interesting as well. So the topic is image generation, but because it is very hot today with LLMs and large language models, I wanted to start off by just touching on that just briefly. Let's see. So large language models have really captured a lot of our attention today. And rightfully so, their advancements have been quite amazing. But as we're focusing on these LLMs, we have also forgotten some of these, or maybe missed out on some of these other advancements in other areas, for example, image generation. So I wanted to create this presentation to give you a good kind of summary of what has happened in these last 2 years, as well as some of the like where the technology is currently at, so that you can know how usable this is for you today. We will cover things like text, how to transform a text description into an image, as well as how the latest and the best deepfakes are created. Then we'll speak about how you can get more control over the generated images. And since there's such a vibrant ecosystem around open source here, we will also look into that. To conclude the presentation, I want to talk a little bit about what I think is coming next and how these advancements in image generation can really lead us to more intelligent large language models. So let's dive in. My name is Olof Harrysson, and I'm a machine learning engineer at Modulai. And we are a small consultancy, primarily based in Stockholm, but we have a growing Gothenburg office. So if you're looking for a job or just want to have a project, then please come and talk to us today because all of the management is here, so it's a good opportunity. We have a booth. Myself, I'm born and raised here in Gothenburg, en riktig göteborgare. And let's see, yeah, I have a computer vision background. And another reason why I wanted to have this talk is because I've long been interested in this surreal nature of AI-generated images and art. And I was hoping that I could rub some of that interest off onto you. Before Christmas, I was working on a project together with Bonnier News. And what we built for them was a platform where they could generate the images that they really wanted for different ad campaigns. The benefit here is that they could kind of we could tailor the system for them so it worked well for them. And the problem that they had beforehand was that they were using a stock photo platform that sometimes gave them a little bit too American-looking images, while they needed more Scandinavian-looking images. But another problem was also that this platform, sometimes it took a long time to find the right image. So if you think that this sounds interesting, then please go onto our website and you can read more. So let's talk a little bit how it's possible to do this generate these type of images. And if you were at the talk with Katarina with NVIDIA, then you got some sort of introduction or a little bit more details there, I guess. But it's all thanks to these diffusion models. So the way that it works is you start off with a clean, normal image, and then you iteratively add noise to that image until it becomes pure noise. There's no information left. Then you train your AI or your model to reverse this process by reducing or removing this noise that you just added. And you use the intermediate steps into your loss function to help guide it. You also can, or you should also use a description of this image. In this case, that would be a seagull drinking a milkshake, to further guide it, to help it know exactly what image it is trying to create. And if you scale this up to millions of images, you end up with a new model that can create different types of images based on the text description that you give it. And you can see here that the model is working in iterations. So for each iteration, it improves the image a little bit. After this presentation, I want you to remember 3 names, and that's the leading models that you can use today to generate images. It's the MidJourney model, the Stable Diffusion model from Stability AI, as well as DALL-E from OpenAI. And they've been around for about 2 years now, and they've been progressively getting better. And I want to compare some of the results from 2 years ago to the images of today, so we can see how quickly we made progress. So these are the images from 2 years ago, and you can see that they're pretty impressive, but wait until the next slide. These are I think the best looking images of today, made with the model MidJourney version 6. And you can see that they're really photorealistic, or I mean, maybe you could tell that these are generated by AI. There's a giant strawberry there. But apart from that, it's really impressive. And this is another model, Stable Diffusion version 3, which got announced just a couple of weeks ago. And it has since been, well, I suppose it's not been released yet, but it's going to come pretty soon. And what's interesting about this model is that it is released open source. So people like myself can build upon this work, and we don't have to spend millions of dollars to train the model from scratch. Then the third model is the DALL-E model from OpenAI. And this one you can actually use directly from ChatGPT if you're a subscribed member. OpenAI has a little bit more of a cartoony vibe to their images, but they're really easy to get some good results. Oh, there's no glass for me. Oh, I'll take this one. Okay. All right. Sorry about that. Okay, so you have 2 solutions now if you want to use one of these models. And you can go the managed solution route, where you sign up on a platform and you pay them money, and then you can generate images to your heart's content. And this is really easy. It's accessible for new people. The other alternative to that is that you host the models yourself, your own software stack. And this is a little bit more tricky, especially if you're not a developer, but it offers you some pretty good positives as well. You get more control over your data. So if it's sensitive data, you don't have to send that all the way to some American server. But you can also customize this often open source solution to better fit your own needs. And let's talk a little bit about open source models, because there are a lot of them built on top of this Stable Diffusion model. And each model can be specialized in a specific style. So you can have a model that has the style of anime or cartoon, or even a model that is specialized in portraits of humans. You can see here in the bottom left that there even is a model that is specialized in spaghetti images. For whatever reason, I have no idea, but it's out there and you can use it. And I think the results are actually pretty kind of cool, and also they're new. It wasn't possible to do this before. So how can you train one of these models? Well, the first way I'm going to talk about is how you fine-tune a model to do this. So you gather up a data set of images that corresponds with this style that you're looking to get. Maybe spaghetti images, if that's your thing. And then you simply do a normal fine-tuning of your model on this data set, and the output of that will be a new model that can create these spaghetti images. Unfortunately, this is a little bit prohibitive in that you need a big computer to do this. So there's an alternative to this, which is called a LORA model. And the LORA model is just this really small adapter model that you can kind of plug in to your existing big foundational model. And that way, you can only train the small LORA model in the same fashion, but it's much easier for people who don't have this big computer. And what can you create? Well, you can create characters, deepfakes. So this LORA is called JFK LORA. And they trained on a few images of JFK, and then suddenly you can do deepfakes. As we heard from Katarina's talk, you can do it in just a few minutes even. But you can train on more abstract kind of concepts. For example, this one called Detail LORA. Here they trained on images that were really detailed, and that way you can generate images with more details. And the LORAs are modular, so you can even combine them together to get both of these effects. And you can see that the image to the right has a little bit more detail than the other one. An honorable mention is this model called Instant ID, where you can create deepfakes, but you don't have to train it at all. You actually only have to Google Instant ID, and you click the web page, and you can do images with this one. But you do need a reference image. So I'll leave it up to you. Do you think that my deepfakes here are good? I'd say they're pretty decent, maybe not as good as Taylor Swift, but still not bad. And this leads me to another part of this presentation that I think is really important. And that's how you can use these different models to get better control over the output. Because if you've ever been in the situation where you prompt these models to try to generate images, you can know that they're a little bit misbehaving and trying to get your vision into a text prompt and then have that image come out in the other end. It's just not always working as you think it should. But there are good techniques and very easy techniques out there. The first one is called regional prompts. And here you kind of build up an image of smaller prompts so that you can get more control over where these different objects should be. Then we have another technique called inpainting. And inpainting has been around for some time, but it's now supercharged due to diffusion models. So you take an existing image and you want to edit that. So you mark an area that you want to change, you give it a prompt, and then it will generate new content within that area. But the best model to assert control over the output, I would say, is the ControlNet model. And the ControlNet model has become really popular. It is allowing you to input like other types of information than just a text prompt. For example, a depth map or an edge map. And this you input that together with your text description, and then the output image will match both of these two inputs. Or you can actually even add 3 or 4 inputs if you have that. So here's an image I did with the help of ControlNet. It's a Gothenburg tram around Kungsportsplatsen, I believe. And I think it's pretty fun to work with these techniques as well, and they look cool. So I hope I've given you some sort of summary of what's possible with today's technologies, but it's still not, there's still some challenges left for us to solve. And the first problem that I want to highlight is that these models are biased. And this bias can really cause problems when you want to put them into production. Right. And there have been attempts at debiasing these models, but it's not always so successful. We heard from Jacob's introduction talk about the Google Gemini fiasco, where they started to generate images of people that were historically inaccurate. People of, or black Nazis, or Indian American Vikings that never existed. So now apparently I didn't know that. It was shut down, that part. The second problem is that these models are really difficult to use for normal people to get good results. A lot of the images that you see, you actually spent a lot of time to get that kind of result. And it's even like people who are enthusiastic and work with these models and know a lot of things about them, for them it can be kind of tricky to get good results. So we still need to wait for a little bit more maturity within this world before this technology really can go mainstream. But I don't have so many fears about that, because we come a long way in just 1 or 2 years. And I think that if we wait another 1 or 2 years, we will really have a lot of this just work better for us. And if we look a little bit to the future, I want to make some predictions. So the LLMs of today, they're primarily trained on text data, and they've learned a lot. But the text data is running out, or they're already trained on all of the publicly available text data. So right now they're also starting to train on other types of data, for example, images. And the advancements that they need to do closely corresponds to the technologies that I've described today. So innovations in one space can lift up this other space as well. And if you think about it, videos is just very similar to images. It's images stacked through time. And video holds a lot of promise for the future, because there's just so much data in videos. There's so much data, there's so much video out there. So if you can learn from video, you have the potential to learn a lot of new information. The problem right now is that nobody has really figured out how to learn efficiently from videos. But I think that this is just a matter of time. And then the question becomes, when they figure this out, what would the new models then learn from video? And this is still an unsolved question. But I believe that they will watch these videos and they will learn about physics. They will learn about common sense. They will learn about humans interacting with each other, how we interact not just with language, but also with body language. And then they will learn about how humans interact with machines, how we use like espresso to make our coffee. And this holds a lot of promise to me, because I think this is a big piece of the puzzle and how we can enable robots into our daily lives, how we can get them into our streets and into our homes to effectively help us do a lot of these things, like help us cook food and things like that. So my question to you is, what do you think that the models will learn from training on video, and when do you think this will happen? Myself, I think that this will come much sooner than we think. I even wager that when they release GPT-5, it will have been trained on video and it will be much more intelligent because of this. So thank you all for attending. That was my talk. Enjoy the rest of the conference.
Thank you, Olof, so much for sharing your knowledge about this topic. I found it really, really interesting. And I do encourage the crowd here to think about your best question. I will start with one question, though. So what do you see as the biggest sort of risk or drawback when it comes to generative AI, specifically image generation? And how do you think we can mitigate those risks? Is it maybe deepfakes, and how can we make the society more aware of this risk?
That's a good question. I do think it is the deepfakes, because already now we're seeing deepfakes really be amazingly good with images. But I think soon we'll also get them like the deepfakes of the video world with audio synthesis, which also work. And actually there's a scam going on in some parts of the world where someone is calling you from the hospital, and when you pick up the phone, it's your kid calling from the hospital saying that they need money for surgery. Send it to this kind of account. And then it turns out it's just a robot doing this. But how to mitigate it, I don't really know. So I'll just think about that a little bit, I think.
Yes. Get back to me when you have a perfect answer.
Okay. Yeah.
All right. Any other questions in the room? Let's start with the person all the way in the back. Yes, you. Oh, hold on 1 second. You will get a microphone so we can hear as well. Yeah.
When I get the output, I mean the image from the output, we don't know the sources that the image has been trained on, right? We cannot know the sources.
Maybe we can know in theory, but we do not know.
We do not know the sources from any of the tool you mentioned, right? Or is there a possibility to know, actually?
So is the question whether we can know if there's been some sort of training material to train these models, and whether, like, if you're an artist, if these models have been training on your images, is that the question?
Yes. So can I know on which images it has been trained? Because I get an output of an image.
Yep.
And can I know the sources that the model has been trained on to get that output?
Well, I think in theory it's possible to maybe measure whether a specific image that is being generated, or more like a specific image that you have created by yourself, if that has been used as training material in a model. But in practice, I think it might not just work that well. So today, I think that there's been some attempts to kind of prove this, but it's a little bit in the gray area.
Okay.
Right. Let's continue on. There was a question, right in front there. Let's, yeah.
Thank you. Great presentation. I have a question regarding what you say about physics in the videos. A couple of years ago, I was working with these pins, these physics-informed neural networks. And my question goes into the direction that if, for instance, you have a video frame where you have a ball that is bouncing, until it stops, it could be that training with video, definitely the model could learn the physics, but will the physics be accurate? In the sense that doesn't the model need more than the video to figure it out, the physics, maybe the equations, like in these physics-informed neural networks?
Good question. I believe that when you combine the knowledge from text data and also with knowledge from video data, you can, in theory, learn physics correctly, especially quite rudimentary physics like bouncing balls. And maybe it will be some sort of approximation of the physics. But if you've seen the results from the latest LORA model from OpenAI, already that model really demonstrates that it can learn a lot of impressive physics just from video. So I guess if you're a theoretical physicist and you need an equation out of that, maybe then you have a higher bar of what like good physics is. But yeah, that's my answer.
Great. Some more questions? Yeah, let's go here on the side.
Hello. So I know this is a tricky one, but I want to follow up on the source material or maybe the legal troubles around this whole concept. So there's a very vibrant open source kind of or open model community around Stable Diffusion, which is obviously a big factor to its growth. Do you have any kind of concrete tips on how to safely be able to launch a product based on these techniques? Because it's such a gray area, at least looking out from the outside in, to know if you can even leverage this open source material or not.
Right. Well, I do know that some of the big platform providers of generative AI services, they're assuming some of the legal risk if you use their API. So if you can find a platform provider who does this for you, then suddenly there is still that risk, but maybe you can wash your hands of it. But in other, otherwise I'm not sure if you can get around that. I guess you can, raise a few $1 million yourself and train a model from scratch, but yeah.
Great. Any more questions right now? In the meantime, I will ask a question. So that's actually on a very similar note to the previous question. So do you see any kind of solution to the problem of like these artists and digital creators having their work like really easily replicated or mimicked by AI models? Or do you think this is now kind of a reality that they will have to learn to like live with?
I mean, it's definitely a problem. And I wonder if how the forces, like economic forces of the world, will kind of solve this, because it feels like they should get some sort of attribution or choice whether they can opt out of being training data. And right now, I think that this technology is so new, so there hasn't been a choice for them to take. But maybe we will have that in the future. But it feels like it has to come from the courts of the big countries of this world for those things to kind of get decided. Yeah.
Great. Any final questions from the? Yeah. Do we have one all the way in the back? Yeah. Yeah.
Hi. Great presentation first. Since the generation of images is starting to increase, is there a risk of training new models on generated images, and what the risk could be?
Good question. I mean, if there's no human in the loop there to validate these images before they get used as training data, I think that there is a risk that these subtle imperfections within this training data that kind of separates them from real images that could potentially lead to the model learning bad things and generating less quality outputs. I don't think that there's any specific risks of these models becoming evil if you do that kind of training, but maybe a little bit worse performance. I guess it depends on if you have a model that produces really weird, bad images, then maybe more of a risk in that case.
Thank you.
Right.
Thank you.
Olof, it has been our privilege to have you on stage. Thank you so much for your talk.
Thank you.